guys. Okay, so today we're doing 9-2. We're graphing quadratic equations again, but the reason for graphing them is to find the solution. So the solution to a quadratic equation is where it crosses the x-axis. So we can have one solution, no real solutions, or two solutions. Normally it would be two, because it's a parabola, it would cross in two places, but we could have those three options. So for the first one, we're going to graph this. So just like I showed you the other day, you're going to start with your axis of symmetry. So x equals negative b over 2a. So we're going to have negative 4 over 2. So our x is negative 2. Plug it into this. And solve it. So when we solve that, we get y equals negative 1. So where we're starting is negative 2, negative 1. So when I start at negative 2, negative 1, that's here. So since my coefficient is 1, which is a positive number, I know that it's a smiley face, and I'm going to use the rule 135. So up 1 over 1, up 1, 2, 3 over 1, and up 1, 2, 3, 4, 5 over 1. And then you do the same thing on the other side. And when you connect your dots, you can see that it crosses the x-axis at those 2 points. So that's your solution. So there's two solutions, and the two solutions are negative 1 and negative 3. Just as an aside, the 135 rule, you can only use it if you have a whole number, two whole numbers for your axis of symmetry. If you don't, then you can't use it. Okay, so the solutions. Those were the two solutions because that's where it crosses the x-axis. Next one. Okay, so the directions are to solve this by graphing. So first thing is, this is on the wrong side, so I'm going to add it to both sides. So I have x squared minus 6x plus 9 equals 0. Then I have to go find my axis of symmetry. And then plug it in. So I wind up with 0. So my axis of symmetry is 3, 0. That's my starting point. 3, 0 is here. And then since it's positive, it's a smiley face. So up 1 over 1, up 1, 2, 3 over 1. Now this solution is at 3. So my solution here is 3. And this is called a double root. Doesn't seem right because it only crosses it in one spot, but it is right. And you'll find out why in the next couple of sections, but this is called a double root. And then the last one. So again, we start with our axis of symmetry. So x equals negative b over 2a. And when we solve that and plug it in, I wind up with 3/4 as my x coordinate. When I go back and plug that in, when you solve that, you wind up with y equals 3.875. So your axis of symmetry is 0.75 and 3.875. So obviously you're just going to have to guess where that point is, and you can't use the 135 here. So 0.75 is here, 1, 2, 3, goes up here. Now the thing about this is positive. I know it's going to be a smiley face. I'm just gonna try to, since I'm looking for the solution is where it crosses the x-axis, I need a couple more points. I can easily get one more point by using my y-intercept. So if my x was 0, my y-intercept is 5. So I have another point, so 0, 5 is here. And I can kind of guess where my other point is going to be, up here, only because I already know the solution. This is never going to cross the x-axis, so this one is no solution. So if it's above your x-axis and we have a minimum, it'll never cross it. If we had another equation or another example that was below the x-axis and it was a maximum like this, it would never cross the x-axis. So this would also be an example of no solution. And that's it.